So picking up with some different things involving probability rules and two-way tables. So the we're going to kind of revisit some different things with two-way tables, which we did from back in chapter 1. And it says here, when finding probabilities involving two events, a two-way table can display the sample space in a way that makes probability calculations easier. So it says, suppose we choose a student at random, find the probability that the student, and I'm looking here A, B, and C, the parts here. So here's the two-way table, and they broke this out by gender, male and female, and they want to know whether those individuals have pierced ears or not. So what we have here is for the males, 19 males had pierced ears, 71 did not. There were a total of 90 males. 84 females had pierced ears, 4 did not, for a total of 88 females. And then at the bottom here, we have of the total numbers of those that have pierced ears. If you put the men and the women together, there's 103 that do, 75 that do not, and there's 178 total males and females together in the table. So at the bottom here it says define event A. Define event A is male and B has pierced ears. So the question here for part A, what's the probability that someone has pierced ears? So what we're going to basically do here is we're going to take how many students have pierced ears, which would be 103, and then this would be over the total number of students, which would be 178. So that's part A. Part B is a male with pierced ears. So let me kind of sort of clean up this here. So for part B, what we're looking at here is a male with pierced ears. Well, there's 19 males that have pierced ears, and that's out of a total of 178 people. So it's still out of 178 because we're still talking about the total number of people that are in the table there. And then part C, it says is a male or has pierced ears. So just be careful with your math here when you go to do this. So we have is a male, right? So we know that there's two different groups of males. There's the 19 and there's the 71 for a total of 90. And then we have the pierced ears group, which is the 19 and the 84. But just be careful with this 19. We don't want to count that 19 in both the male group and the pierced ears group. So, when we go to do this, what we want to add is 71, 19, and 84, which is what we're doing here. And once again, out of the total, which would be 178. So this would be 174 out of 178 for part C. So some other things involving two-way tables, and if you've ever seen these before, probably would help you. This is what's called a Venn diagram. And a Venn diagram is simply just a different way of looking at a two-way table. And what we have here, we're referencing the previous example. So this circle right here is the probability of A, which is the probability that someone's a male. And then this circle here, the blue circle, is the probability of event B, which is the probability that someone has pierced ears. And then this shaded area in the middle here, this is the probability of A and B, meaning the probability that someone is male and has pierced ears. So it's the probability that someone is a part of both of these groups, both the male group and the pierced ears group. That's what this is right here. So Venn diagrams can be very helpful with finding the probabilities of different outcomes. So we talked previously about the rule for mutually exclusive events and the addition rule. This is more of sort of the general rule for two events. So this is the rule that you would use when events are not mutually exclusive. So we would say that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that was kind of what we just did in that previous example with part C. So from a notation standpoint, just notice here that we've replaced or with this U, and that U is red here. This is red, A union B. And then here what we did is we replaced the and with sort of like an upside down looking U here, and we read this as the probability of A intersects B. So just some different some different notation type things there. So if you see this U here like this, that really means or, and if you see this sort of upside down U here like this, that really means and. So here's an example, and it says a standard deck of playing cards with jokers removed consists of 52 cards in 4 suits: clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominators ace, 2, 3, 4, all the way up to the king. The Jack, Queen, and King are referred to as face cards. Imagine that we shuffle the deck thoroughly and deal one card. Let's define events A. A would be getting a face card, and B would be getting a heart. And question 1 says, make a two-way table that displays the sample space. So when I'm going to make this two-way table here, I'm going to do this as event A and event B. So one side of my two-way table is going to be whether or not I get a face card. And then the second side of the two-way table is going to be whether or not I get a heart. So I have the two-way table broken out like that. So there's 3 hearts that are face cards. There are 10 that are not, for a total of 13 cards there. And then I have 9 cards of the non-hearts. That would be the diamonds, clubs, and spades that are face cards, 30 that are not. So this would be a total of 39 here. So that's the two-way table. So then the question here says find the probability of A and B, meaning find the probability that a card is both a face card and a heart. So when I go to do this, okay, that's simply just 3 out of 52. So face card and a heart, so just keep in mind, whoops, let me kind of come back here. So face card and a heart, that's this group right here. Okay, so that would be 3 out of, remember the total of all these is 52. And then part B says, explain why the probability of A or B does not equal the probability of A plus the probability B. Then use the general addition rule to find the probability of A or B. So when I go to do this, number 1 for this right here, the events are not mutually exclusive. So because of that, I cannot use this formula here. I have to use the general addition formula. So that's the general addition formula would be this right here. So if we're talking about the probability of A or B, meaning the probability that you would choose a card that's a face card or a heart, I would do the probability of A plus the probability of B minus the probability of A and B, which when I do that, I get a value of 0.423. So some different things involving complements and some Venn diagram type things. And Venn diagrams are very good at identifying what are called mutually exclusive events. So just remember, mutually exclusive is 2 events that have no outcomes in common. So when we're talking about Venn diagrams and the complement of an event, so here is the circle that would represent event A, and then everything that would be outside this circle, okay, we would say is the complement of A. And if you have 2 events that are mutually exclusive, what that basically means in sort of Venn diagram speak is you would have 2 events, you'd have 2 circles right here, A and B, but there would be no overlap amongst the 2 circles because they do not have any outcomes in common. So if we're talking about the intersection of A and B, meaning the probability of A and B, now what we do have here as far as Venn diagrams go is you have here's circle A and then here's circle B, and then this green section in the middle is the intersection or the probability of A and B, the probability that they both occur. And then you have this whole A union B, which is another way of saying A or B. So if you have A or B, that's the probability that either one of these occurs. So that not only includes the intersection, but it also includes the parts of the circles where there is no intersection for something like that. So it says here to keep the symbol straight, just remember U is for union and the upside down U is for intersection, and I kind of bolded the N here in intersection since you could kind of make an argument that maybe that looks a little bit like an N there. So coming back to the same two-way table involving gender and pierced ears, so we're defining the event A is that someone is a male, event B is that someone has pierced ears. And this is what the Venn diagram would look like for something like that. So here's event A, right? Someone is male. So remember, there's 90 males. So there's 71 males that do not have pierced ears. There's 19 that do. And then here's event B, and that is that someone has pierced ears. So that's this group right here. So you have 19 of those that are male and 84 that are female. And then you have 4 here that are in the group of people that are female and do not have pierced ears. So when we start to talk some different things with probability for something like this, right, the intersection of the two circles, which is this area right in here, there would be 19 of those that that are male and have pierced ears. If you have inside circle A but outside circle B, so that's inside circle A, outside circle B would be here, you're basically referring to the males that do not have pierced ears. And that would be 71 of those. And then if you go inside circle B but outside circle A, which would basically be this right here, that's 84 people that are female and have pierced ears. And if you're outside both circles, that would be the group of females that do not have pierced ears. And here is the notation that you would use for each one of those different types of outcomes there. So a different example, and it says, according to the National Center for Health Statistics, in December 2008, 78% of U.S. households had a traditional landline telephone, 80% of households had cell phones, and 60% had both. Suppose we randomly selected a household from December 2008, and it says to make a two-way table that displays the sample space of this chance process. So what we're looking at here as far as the two-way table goes is we're looking at cell phone versus no cell phone, landline versus no landline. So we have 60% of the group that has a landline and a cell phone, and we have 18% of the group that has a landline but no cell phone, 78% total there. And then we have the group that has a cell phone and no landline, that's 20%, and then the group of people that have no telephone at all, and that's 0.02%, and there's the 22% of those that have no landline. So it says to construct a Venn diagram to represent the outcomes of this chance process. So if we're talking about a Venn diagram for something like this, we'd have event A is someone has a landline. So there were 78% of the people that did not, or that did have a landline phone, 60% of which have also had a cell phone. And then you have the group B, which is the cell phone group, and then there were 80% of the people that had cell phones, and within that 80%, 60% also had the landline. So, and then here's the 0.02% that had neither type of telephone. So question 3 says, find the probability that the household has at least one of the two types of phones, meaning they have a landline or they have a cell phone. So for something like this, I'm going to do the probability of A plus the probability of B minus the probability of A and B, because the events are not mutually exclusive. So to do this, I would say the probability of A, which would be 0.78, plus the probability of B, which would be 0.8, minus the probability that they have both phones, which would be 0.6. So this comes out to be roughly about 0.98. So we would say that if we were going to choose a household at random, we'd have a 98% chance that we would choose at least one of the two types of phones. And then question 4 says, find the probability that the household has a cell phone only. So a cell phone only would be the group of people that do not have a landline, and only have a cell phone. Well, the probability for that would be just 0.2, which if you come back to this Venn diagram here, that's this group right here. So just some things with your calculators and probability. So just kind of have a note here. Many probability problems involve simple computations that you can do on your calculator. And this is more just in sort of things to just remember with free response questions. And it says it may be tempting to just write down your final answer without showing the supporting work. Don't do it. And what they refer to when you do that is they refer to that as a naked answer. And even if it's correct, what will happen is you will not earn the maximum amount of points that you could possibly earn on a free response question, okay, if you don't show some type of evidence of where your answers come from. So some things that we'll look at next involving probability, the big thing that we'll look at next is what's known as is what's known as a conditional probability, and that's when you try to find the probability of something knowing that something else has already occurred. Some other things that we'll look at next involving probability is the whole business of what's called a multiplication rule. We've looked already at an addition rule. We're going to look at some things with a multiplication rule, and then we'll also get into some different things with conditional probabilities involving two-way tables and what are also called tree diagrams.